course, these are all correct answers.
Mostly. Actually, it's the only one I didn't get 100 on. I think.
What do we have? So exam one, let's go back and really dust things off. Our first exam, it covered chapters 1, 2, 3, and 4. So the first chapter was kind of getting used to the body, the cavities, directional terms, regional terms, things like that. Then we did chemistry, electrons and protons and stuff. Then we went to the cell. For our purposes, they were our smallest living thing. And then we went to tissues. So we hit those 4 basic tissue types and went from there. So that was exam 1. I guess I don't need to hide nothing, do I?
No.
So bone. With bone and blast. Blasts create, right? So if you're gonna have a blast and you're referring to bone, it'll be an osteo. Osteo refers to bone, blasts create. So fibroblasts, they're in the connective tissue, they make fibers. Osteoblasts, they make bone. What do you think that's gonna make? I think that's a made up word actually, but I was thinking it makes blood. Hemocytoblast, yeah, I think that's actually made up. Maybe not. Chondroblast, what do they make?
Cartilage.
Cartilage. Chondroblast makes cartilage. So yep, that's osteoblast. Ooh, isotopes. What chapter do you think that's from? It's the chemistry chapter. So with isotopes, I won't draw on your.
Oh, it's okay.
Isotopes, it says the same number of blank, but different numbers of blank. They have the same number of protons and different number of neutrons. If I was to add protons and neutrons together, what do I make? Atomic mass, yeah. Charges on these things. Protons, what are protons?
Positive.
Correct. Protons are positive. Let me get some pictures up here as well. Protons are positive. Neutrons, what's their charge? They don't have one, it's neutral, good. Protons and neutrons, where are they found? In the nucleus. Now with nucleus, we've looked at a cell nucleus, right? But now we're also looking at these atoms and elements nuclei. So they have protons and neutrons in there. And you already told me that when you add up protons and neutrons, you get the atomic mass. Now, well, we're not talking about isotopes right now. If a certain atom has an atomic number of 6, how many protons does it have?
6.
It has 6. So that atomic number, where's 6? Right there. So that's the atomic number. These are all atomic numbers here, the superscript. So that's atomic number 6. So that's telling us we have 6 protons. Ooh, these things are neutral. So what we also have 6 what? Electrons, yeah. 6 protons, 6 electrons. So our net charge is 0. If any of these atoms or elements had a charge, what would you call them? An ion, yeah. You'd call it an ion. What else do we got? Well, you want to keep going with chemistry or just keep going with the exam questions? Because I was going to go one direction here. Shells around our nucleus. Here's our first shell. Let me make it larger for you. How many electrons maximally can this first shell hold?
2.
Good, maximum of 2. You put 2 electrons out there, that shell is filled. Then you gotta go to a second shell. How many maximum can that hold? 8. And then if I was to draw a third shell, how many maximum? 8, yeah. And that's as far as we're going. So this first shell can hold a maximum of 2. Second shell can hold a maximum of 8. When you're throwing in electrons with these shells, you start with the innermost shell first. If I use the word valence electrons and I point to this hydrogen, how many valence electrons does it have?
1.
1. That just means how many electrons are in the outermost shell that, if it's incomplete. How many valence electrons do we have here for lithium?
1.
1. How many more electrons can hydrogen, how many more does it want? 1. It wants 1 more. It wants to be filled. It wants to feel complete. We all do in life, right? So, how about lithium? How many more does that need?
7 more.
7. Yeah, needs 7 more. Okay, how many more can helium hold?
None, without going to another shell.
None. It's full. It's very noble. Now let's jump to bonds. If elements or atoms are sharing electrons, what kind of bonds are those? Sharing it. Covalent. If it's an equal sharing of electrons, it's still covalent, but what would you call it? It doesn't have any poles. Nonpolar. Yeah, nonpolar covalent. If it's an unequal sharing, then it would be polar. Okay. The example that we used for a covalent bond, it's our biological solvent. I was drinking it out of my water bottle. Bourbon, you're right. No. I don't even know what that is. H2O, yes. So holding the hydrogen and the oxygen together, there's H2O. These two are hydrogens, right? This is oxygen. This is a covalent bond. Now, if I was to, before I do that, this is water, right? A water what? Water
Molecule.
molecule. All right, good. Water molecule. Now I'm going to join, oh gosh. Yeah, that's okay. If I was to join 2 separate water molecules together, what kind of bonds connect 2 separate water molecules together?
Hydrogen bond.
Hydrogen bonds, yeah, good. Hydrogen bonds. Now, this is a covalent bond. Here's a hydrogen bond. Which ones are stronger?
The covalent bonds.
The covalent, yeah. They're the strongest bonds. Which ones are the weakest?
Hydrogen.
Hydrogen. Well, for our purposes, we only went over one more type of bonding. What's the one we didn't talk about?
Ionic.
Ionic bonds. If you had to describe ionic bonds, what do they do with their electrons?
They like give them away.
Yeah, they donate them, they can give them away, or they can accept them. What did we use for an example for that one? Salt. So if let's draw this one out actually. What's Na? Is that 11? It says Na11. How many protons we got? Yeah. How many electrons we got? Yeah, we still got 11 for just the atom right up there. Right now it's neutral. Now let's draw some shells. Here's our first shell. How many electrons can we hold?
2.
2. How many do we got to play with? We got 11. We just used 2. So now what do I gotta do?
Another shell.
Draw another circle. How many is that gonna hold?
8.
8. So what we did, there's 8, 9, 10. What do I gotta do now?
1 more.
1 more. And then what do I put on this 1 more circle?
1.
1 more electron. Now let's find Cl. Where's Cl? Oh gosh.
17.
17? Ugh. Let's do this for Cl then. The atomic number is 17. How many protons we got?
17.
How many electrons?
17.
Now I'm gonna draw this even smaller so I can fit it. First shell,
2.
I forgot already. How many does that hold?
2.
2. Second shell,
8 more.
we got 8. We got a third shell. How many more electrons we got?
8. Well, 8 can fit.
I lost count. We had 17. How many was this?
That's 10.
10?
Uh-huh.
So I gotta draw 7 more? Did I just draw 8?
No.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wait. 1, 2, 3, 4, 5, 6, 7. Okay, I drew 7. Good. Now with these ionic bonds, before I talk about them more, how many more electrons can this chlorine hold?
1 more.
Well, it wants 1 more. What about sodium? How many can that hold? You're gonna go 7 more. In this case, sodium, it's like, well, you know what? I'm gonna donate my electron to this chlorine. So if sodium gets rid of an electron, it gets rid of a negative, what does it become?
Positive.
Positive. So now it's an ion. So it donated an electron. It said, here you go, take this. Now if this chlorine accepts an electron, so it's right now it's neutral, but if it takes on 1 more negative, what's it become?
Negative.
Yeah, it becomes negative. There's gonna be this attraction between the two, an electrostatic attraction. And the sodium, this chloride, becomes salt. Individually, these atoms, they kill you. But when they start sharing electrons, it's like, oh, okay, I'm gonna go sprinkle you on my food. And it's okay. Well, I guess in moderation it's okay. So those are the ionic bonds. What else? If I gave you something like this, there's the symbol. We don't know what the symbol is. And I gave you the atomic number of 5. Just from that information, what could you tell me? And it's a neutral particle.
It's got 5 protons.
Yeah. We know how many protons it's got. How many electrons it got?
5.
If we're not taking that thing down, what else could you tell me? Could you tell me its symbol? What is it? What letter is it?
B.
B. What the heck's B? I don't care. Doesn't matter. It'd be a B. Now, from the information that's up there, what's the number that's under B? I never used to have to walk.
10.811.
Yeah, 10.8. Oh, wow. My eyes are getting bad. Yeah, 10.8. What number was it? My memory's getting bad too.
10.8.
Oh, okay, 10.8. I may have done that to be a funny guy. 10.8. What's 10.8 represent? Awesome, the atomic mass. Oh, atomic mass. What two numbers do we add up to get the atomic mass?
Protons.
Protons and neutrons. So we're going to round that to 11. Can we figure out how many neutrons we have?
You can subtract.
We can. Look at that. We got the P for protons. We have 5 plus neutrons equals, what is it?
11.
Oh, and then it becomes an algebra problem. So how many neutrons we got?
6.
Nice. Oh. Well, let me hit the AF button. Autofocus. Good. There's a little bit of chemistry. Oh, then we jump to body planes. Let me go ahead and see what we got here. There we go. Let me jump to some more chemistry questions. Atoms are electrically neutral because protons and electrons are equal. Sure, I think we would have got that one. Heart muscle, no. External, no. The atomic number of an element is 7. How many electrons does it have? It's gonna have 7. How many protons will it have?
7.
7. Good. The atomic number of an element describes the protons and neutrons. Oh, sorry, protons in the nucleus, sorry. Based on what I just said, protons and neutrons, what would that give you? The atomic mass, yeah, all right. Man, this was a long time ago, wasn't it?
I think there was more a little bit further back. I think there was at least one more chem question.
Well, I could make that a little larger for you too. Maybe whoever this test belonged to, maybe that person got this wrong. Maybe not. What do you think the answer is?
Let's see. I got that one.
Yeah, that's right. So, yeah. The atomic number of an atom is 6, the atomic mass is 12. 6, we could say how many protons we got. We know the atomic mass is 12. Protons plus neutrons equals that atomic mass. You can do the algebra and say, okay, 6 plus what is 12? 6 plus 6. Nice. All of that information just went in through your otic area. Okay, good. First energy level, I think I called them shells. Ah, good. I said shells, so you can also refer to them as energy levels. First energy level holds 2. What about the second and third energy levels? How many does those each hold?
8.
Oh, okay, 8. Good. I think she might have got this one wrong. The atomic mass of an atom describes the. What do you think the answer is?
E.
It's
Total
E.
weight of both.
Yeah. Protons and neutrons. No, I'm not. All right. So, that was a real quick one on chemistry. Was there any chemistry questions that you want me to go over again? Not again, but go over, because I definitely jumped in that chapter. Let me just see if something comes to mind here. Oh, gosh. I think there were some questions about this. If I say monomer, what's an example of a monomer for sugar? Glucose. What's a polymer of sugar? Glycogen. Woo, beauty. Glycogen. Monomer, or a mer, of protein. The smallest unit of a protein.
Amino acid.
Amino acid. How about a polymer of protein? Polypeptide, yeah. I was like, a protein, yes. Polypeptide. A term for fat that I'm going to use for energy and storage of energy. Ugh, gosh. Yeah, it's lipid. What's our storage form of, what's the lipid storage form? It's got 3, I heard it. Triglyceride. Yeah, I didn't know how to ask that properly. I'm shooting from the hip here. Triglyceride. If you had to describe this triglyceride and it's solid at room temperature,
No, it's saturated or unsaturated.
saturated. If it's liquid, it would be
Unsaturated.
unsaturated. This lipid is very important for a plasma membrane. It forms a,
phospholipid.
yes, good. I was gonna say it forms a bilayer, a phospholipid bilayer. Steroids. If I say steroids, does any terms come to mind? Estrogen, testosterone. Cholesterol. Ooh. Cholesterol. Where do we find cholesterol? Well, never mind, that's a stupid way of asking it. What's cholesterol do for our phospholipid bilayer? We put cholesterol in there to do what? It structurally, it makes it, I don't want to say stiffens it, but it adds strength to that phospholipid bilayer. Cholesterol, it adds strength to that phospholipid bilayer. I think it was an actually question in exam 1, somewhere in there. Yeah, whatever. It's in there somewhere. Now, let's take these monomers and we're going to join them together to make a polymer. When we're joining them together, we are kicking out a theoretical water. What process is that? Joining 2 things, kicking out a water, we're dehydrating it.
Dehydration synthesis.
Dehydration synthesis, yes. So we're building things up. If we're building things up, there's a general term for to throw up. Vomit? No. It's an anabolic type of a reaction. Anabolism, it means to throw up. What's the opposite of anabolic?
Catabolic.
Catabolic, that means to throw down. Be throwing down after the practical. No. So we're breaking things down. Catabolic, break things down. During catastrophes, things fall apart. With these catabolic reactions, if you're adding water to split things, what's that synthesis called?
Hydration. Hydration.
Hydrolysis. Hydro and lysis. You're breaking things apart with water. What's another term for hydrolysis? I just ate my food. What's happening now?
Digestion.
Digesting. I'm digesting my food. They're hydrolytic types of reactions. Whoa. Yes. Look at me. I put my markers away already. I'm mailing it in today, aren't I? Doesn't matter what A and B is. Well, actually, generic terms or general terms. A and B. If you had to use terms for what A and B represent on this side of the equation, what are these? Reactants. And they yield a new product. Beautiful. So we got these two reactants together. We yielded a new product. What type of reaction is this? Dehydration. If I was to do, what's that? Catabolic type of reaction. It's breaking it down. That could be anabolic, that could be catabolic. Now, let me do this one. A, B, C, D. Okay, good. I had to get that one. AC, I better go B, D. No DB's in here. All right, what's that? That's an exchange reaction. AD, whatever. That's an exchange. We exchange those letters. And, in theory, all of these reactions are considered what? Reversible. Yeah.
Aren't the first two only considered dehydration or hydrolysis reactions if there's water?
If there's a water, yeah, H2O. Yes. Decomposition.
I think there was a question
Yeah.
about decomposition in, I think it was that one.
Let me see if I got a picture. Yeah, because I never stuck a water in there, so Oh, how about you look at two? No. It was in here, I thought. Not this one. I might have lied. We looked at exchange reactions, didn't we?
Mm-hmm.
Might have been from a previous semester then. Was it a different chapter? Thought I had a good picture for you. Where they're showing the exchange and anabolic and catabolic type of reactions. Chapter 3? Don't think so. Chapter 1? Maybe just a generic picture of it? want some narrated ones? There. Well, they're showing you, oh, another synthesis. No, I think I said the word synthesis. They're showing you synthesis, there's dehydration, now the actual water is represented properly there. Yeah. Oh, condensation. Good grief, there's another word. Condensation. And all of these can be reversible in theory. Here's our exchange. And there they are being reversible. Potentially. All right. Chemistry bag. Got some old exam stuff there. Was that from one? Yeah, it was. What else, anything else for chemistry? Want to look at chapter 1 or chapter 3 now? Actually, how are we doing for time? Oh, 6 minutes. We can do a speed round for one of the chapters.
You pick, dealer's choice.
Ooh, good. We'll do, what's this one? That's chemical, we don't need that. There's one. One's up. One's too easy. Let's do, well, 3 cells. You've seen cells so many times. Cells more than you like. If I say biological levels of organization, starting with the smallest level, what's the smallest level?
Chemical level.
Chemical level. Then we get groups of chemicals to form molecules, then what do we make? I may have lived in one. Cell, yeah. That's another story though. It wasn't me, it was the other guy. The eye patch and the limp. Yeah, so cells. So chemical, cellular level. For our purposes, what's a cell? Smallest what?
Smallest living unit.
Smallest living unit. So cells are the smallest living unit. You're welcome. You get groups of cells together, what do you make?
Tissue.
I was going to point to it. A tissue. Tissue right there. How many basic tissue types do we have?
4.
4 basic tissue types. Now, what are the names of the 4 basic tissue types?
Connective.
Connective?
Epithelial. Muscle.
That's supposed to be
muscular.
Muscular.
Nervous.
Nervous. I forgot which one what did we start with? Connective. Oh, there's one last one.
Epithelial.
Epithelial. So we have epithelial, we have connective, muscular, and nervous tissue. 4 basic tissue types. Now we get those tissue types and we put them together. What do we make?
An organ. An organ.
An organ. You got an organ. What's an example of an organ?
Stomach.
Kidney. Good. Now we get groups of organs that function in a similar manner together. What do we make?
An organ system.
Organ system. How many organ systems we got?
11.
There's 11. You said kidney, or we said kidney. You guys said kidney. What organ system does the kidney belong to?
Urinary.
Urinary. Now we get all 11 organ systems together. What do we make?
An organism.
An organism. Beautiful. These organ systems can function together and they try to maintain what?
Homeostasis.
Woo! Homeostasis. Awesome. the mechanisms to maintain homeostasis, what are they called?
Positive and negative feedback?
Yeah, positive and negative feedback. An overwhelming majority of our feedback systems are what?
Negative.
Correct, negative. If, this is where we'll end on this one. If I have a fall from homeostasis for a long enough duration, what are you considered?
Ill.
Ill.
Sick.
Ill. It's time to get ill. You guys ready to take this practical? All right, yeah, we gotta end. I gotta start this thing.